Hey everyone, welcome back to another video. In today's video, we're going to be talking about the special right triangle known as the 30, 60, 90 triangle. Let's go ahead and let's get started. Here we have a 30, 60, 90 triangle. Alright, and the theorem for a 30, 60, 90 triangle states that if we know one of these sides, okay, let's say side BC here is length S, which is just some random number. It could be 4, 5, whatever. We're just going to put S. We know that the hypotenuse will be 2 times that amount, so 2S. And the longer leg, okay, which AC, would be S times the square root of 3. Okay? So as long as we know what one of these sides is, there's a way to pretty much find what the rest of the sides are. So let's go ahead and add some numbers to kind of help with the context of when and why I would use this. Okay, so here's the 90-degree angle. Let's say it's a 60 and a 30. And let's say they only give me the bottom side and they say this is triangle XYZ. And they say that XZ is the length of 4. Well, if the bottom's the length of 4 and they tell me to find the 2 missing sides, I might panic and say, well, I know the Pythagorean theorem, but I need at least 2 sides to use that. Well, that's the nice thing about a 30, 60, 90 triangle, is that I don't necessarily need to know the other 2 to find any of them. As long as I know one of them, I can find what the other 2 are. So the short leg, if I know that one's 4, I know that the hypotenuse, my long side, is going to be 2 times 4, which in this case is 8. And I know that the longer leg is going to be 4 times the square root of 3. So I put 4 square root 3. And that's how I use the 30, 60, 90 triangle theorem to solve for the missing sides of a 30, 60, 90 triangle. So let's go ahead and let's look at another example problem. So here I have a 30, 60, 90 triangle because we see those angles. And in this case, they actually gave me the hypotenuse and they want me to find the 2 legs. Well, I know that the shorter leg, in terms of the hypotenuse, I know that the hypotenuse is twice as large as the short leg. So I take this 18, in order to find the short leg, I just need to divide it by 2. 18 divided by 2 is just 9. So I know that xy for this problem is 9. The way I find yz is I got to remember that the long leg is the same as the short leg, but we multiply it by the square root of 3. So it's just 9 times the square root of 3, which is just 9 square root 3. And there I have solved for the 2 missing sides of this right triangle. So hopefully now you feel comfortable in being able to solve for the missing sides of a 30, 60, 90 triangle. Similar to the 45, 45, 90 triangles, okay? It's just we use a square root 3 and the hypotenuse is twice as long as the short leg. But altogether, both of these special right triangles are much more faster at solving than it is to solve a problem using the Pythagorean theorem. Okay, so hopefully you feel very comfortable in using this. As always, if you need to rewatch, rewind, go back, look at an older video, do it. Learn math at your own pace. That's always the best. As always, I just want to thank you for watching, and I'll see you guys next time.